Good afternoon, everybody. As you mentioned, I'm Vanessa Little, currently employed by VMware, but more importantly, I'm the current OSM Technical Steering Committee Chair. So today I'm going to be talking briefly about the TSC's perspectives, how the steering committee really looks at the open source community and how we manage it, and looking ahead to Release 5 in a little bit more detail. So, as was previously mentioned, the community keeps growing. We're up to 106 members as of today, I believe, and it's been growing exponentially since Release 0 2.5 years ago. And so this slide should be familiar and just sort of shows the journey that OSM has taken over the past few years, starting at Mobile World Congress in 2016. That was the first working demo that was showcased, all the way up to present day, where we're very close to Release 5 in November of this year. It's been a significant journey in a very short period of time, and that's only really been possible through the immense contributions of not only the community, but some of the vendors that support it and interoperate with it, as well as our involvement with ETSI and other open source communities. So looking at the architecture, what we've done here is we've separated the runtime components versus the design time components. And we'll get into a little bit deeper dive than this, but at the top you see that we have the GUI and design time tools. For open source MANO, because it has an ETSI Sol 5 aligned northbound API, this GUI and design time tools can be whatever you like them to be, provided that you've developed a GUI interface or even an automated interface or an OSS interface that can interoperate with an ETSI Sol 5 compliant API. You can put whatever you like up here for these design time tools. And so that was a strategic initiative that appeared in Release 4, and we've continued to augment that and bolster it a bit in Release 5 in order to make this a possibility, so that not everyone has to use the GUI, not everyone has to use a GUI. If you want to manage everything through the API, you can do that. We wanted to make sure that the door was open to do whatever level of northbound integration various adopters would like to do. And so I think that sort of really leveled the playing field around how OSM can be leveraged and consumed. It can now become a component of a much larger system, or it can be run as a standalone using the GUI interface that comes out of the box with it. So looking at the OSM core components, and I do apologize for the color scheme. It's our OSM marketing slide. But you'll see here that we have the various different components of OSM, starting with the user interface. And as I mentioned, this is an optional component. Any Sol 5 compliant interface can be bolted on here, but out of the box, what OSM has provided is a command line OSM client tool, as well as a web-based GUI interface that's all HTML5 based. Then moving down the stack a bit, we have our service orchestrator components. This is really the logic engine of the whole infrastructure. And in here, the data models are consumed and manipulated and then sent to the various components to do what they need to do. Some of those instructions will be pushed down to the resource orchestrator, and this is a plug-in based engine that communicates with the various Vim and SDN layers to actually deploy and manipulate those VMs and containers moving forward. Some elements in the data model will be pushed to what we call the N2VC. This is an engine that's powered by Canonical's Juju to do lifecycle management of the VNFs once they're deployed, and to be able to push some of that day zero configuration to them, as well as of Release 5, start pulling in some monitoring and telemetry to get us closer to closed loop service orchestration. And I'll touch on that a bit in a minute. And then as of Release 4, we have this module here called monitoring. This is where we start to pull in those, and we start to marry those VNF layer telemetry elements with the infrastructure layer telemetry elements and marry them together to actually make an intelligent decision about service health. This has always been a very difficult thing to achieve for any orchestrator, because different VIMs have different monitoring solutions, different VNFs have very unique monitoring solutions, and each VNF has different data points that are relevant to them. So being able to make a universal engine where you can consume this in a way that makes sense was quite a challenge and quite a feat, and it is definitely still a work in progress, but as of release 5, we will have a working model for this so that we can start bridging that gap and having that type of closed loop service assurance that people have been looking for. So the OSM topology view, as I mentioned, we have the OSM a command line client as well as the lightweight UI, all communicating over the Sol5 RESTful API to this northbound interface. And the information models are pushed, and the VNFD and the VNFD and NSD, network service descriptors and VNF descriptors, are pushed through this interface into the OSM infrastructure. So there's one point of interaction northbound for all of OSM. This was a big pivot in OSM release 4. Previously, we had different interfaces to the various components, and it made integration northbound extremely complicated. You had to learn 5 different northbound APIs and then figure out how to sequence those operations yourself. It was untenable and not very useful. And so now we've married that all together into one common northbound API, so that it's very simple to integrate from the north end. We have the lifecycle control module here, or LCM, and in that is our N2VC component that I mentioned previously. All of these components leverage a shared Kafka bus. So this was also new in OSM release 4, and we're going to continue with this in release 5, where all of these elements can leverage the same bus, and that's how they're able to intercommunicate with each other. So they can all subscribe to the bus, and those messages that are pushed onto the bus that are relevant for that component can be popped off, and new elements that are destined for other components can be pushed on. This also increased our ability to scale significantly over previous releases while having a much smaller footprint. Then moving on, we have the VCA component. This is part of that Juju lifecycle control component. And then we have our resource orchestrator. And as I mentioned before, here's where all the plugins live for all of those various Vim and SDN layers. So by having this type of topology, what we've created is a very stable northbound interface. And because it's all model driven, and as the model evolves, there's not a lot of changes that have to happen in the southbound. So we can start bolting on additional Vim and SDN capabilities by writing more plugins for the resource orchestrator. We can start bolting on more plugins for the monitoring module by adding plugins there. So as the industry evolves and we want to have interoperability with more open source and commercial solutions, the core engine doesn't have to change. The models may change as we continue to align with the ETSI standards and as those continue to evolve. The plugins may change as commercial solutions and open source solutions rise and fall and continue to evolve. But the core logic engine, that architecture is going to be stable. And so that gives us a lot of room to innovate at the edges, as I like to say, or add some clever new features like monitoring, or add some of that logic to do that closed loop service orchestration so that when the monitoring module determines the service health of something that's deployed is no longer viable, it can leverage that northbound interface to be able to heal that service or redeploy that service or whatever it is that you've defined in your descriptor model to do when that failure occurs. Whatever KPI you've defined, when that gets violated, all of this framework is here to be able to leverage that. So we've heard a lot about our alignment with ETSI standards. So here's a listing to date as of release 5, which standards we're aligning to. Now this doesn't necessarily mean that we follow these standards to the letter and have a complete and thorough implementation of them. There are certain areas where we have either extended or omitted certain components that don't apply to OSM. So when we say we have alignment with ETSI standards, it's a best efforts basis where we consume the standards that are relevant to OSM and that make the most sense to the community that's consuming OSM. It's not a firm mandate to say whatever pops out of ETSI is going to be deployed in OSM. We take the best parts, and we also, and as Francisco Javier mentioned, we have this feedback loop back into ETSI so that as we extend those models to add new capabilities and new features, that's communicated back into ETSI so that that community can benefit from the real world practices that we've had with OSM. So as OSM implements and tests and develops these real world use cases, we send that feedback back into ETSI, which is for the most part an academic standards body, to say, you know, this component didn't really work, but if you extend it like this, this makes more sense, and here's why, here's the context around it. And we found this to be a very effective feedback model, and we're going to continue to do that going forward. So looking ahead to release 5, I've touched on a few of the new features, but here are the core themes that you should expect to see in release 5. The first is these multi-site extensions and this concept of WIM management, or WAN as a VIM management. So having multiple VIMs in disparate locations, having OSM be the master orchestrator to be able to do that and start building network services that happen to span multiple VIMs. This is something that's new for release 5. An additional 5G capability. So looking forward to, we've had some demos previously that demonstrated MEC architectures and being able to use OSM to do that, but it all still rolled up to one common VIM. So now that you can have multi-VIMs and multi-locales, it really levels the playing field and opens it up to have these distributed MEC-like architectures or multi-access edge computing architectures where you can have components that live in various geographic regions but are technically all part of one network service. The monitoring improvements. So Release 4 saw the addition of the monitoring module, which was the core engine that allows us to start consuming telemetry from not only app layer things like the VNFs, what's actually happening, number of drop calls, number of simultaneous users, those type of app level telemetry components, and also consuming those infrastructure layer components. How fast is my CPU spinning? Does this VNF, is it pinning its disk? Et cetera, et cetera. So we've extended a lot of different plugins for that with new interop capabilities, but we've also added another module called policy. So being able to, not only are we gathering this data, but being able to make intelligent decisions on it in real time, or as near real time as is feasible. Being able to deploy a policy map of KPIs directly from your descriptor model all the way through, so that when you define your network service, you also define those KPIs that determine whether or not it's healthy. Because for every network service, those data points could be unique. Every VNF, those data points are unique. Even across different VIMs, those data points could be unique. And being able to distill, those 4 or 5 components that really determine whether or not your service is healthy, as opposed to analyzing, a service graph of 10,000 different elements, most of which are probably irrelevant. Being able to distill that into 5 or 6 and sticking that right into your deployment model is what we're going for here. So looking at those few components that determine service health and then driving that through your information model was the goal we were going for here. In improved modeling and networking, we have some enhancements to federated security management with some deeper integrations with Keystone. The multi-VDU VNF support, because as we all know, most VNFs are not just comprised of one VM or one container. They happen to have a number of them that are networked together in a very specific way in order to be effective. And so being able to model that effectively and actually describe that in the VNFD is something that we've added, well, not necessarily added, but just enhanced to make it a lot simpler to do so. And it's a lot more logical flow in the data model. Service function chaining, as Francisco Javier mentioned, we're doing a lot of tests with NSH-based SFC and those capabilities that are very new to our industry. So OSM already has support for that in our data model, as well as some successful preliminary tests. And physical deployment unit support. So now not only being able to orchestrate, do day 0 and day 2 operations of virtual network functions, but also integrating that with the physical network functions. Because in practice, certain network functions might have a physical component like a PE router or an MPLS router, as well as the virtualized components, and the network service is overlaid across all of those. So being able to marry those and bring them in the mix so that your services are no longer chained to your virtualized cloud. You can now extend them into your physical cloud as well and orchestrate that all as one service model. And then the user experience and optimization. We've made it a lot easier to install. Those who might have gone through the pain of installing Release 0 and watching that puppy compile, we hear ya. We felt your pain, and we've made it a lot simpler to install. So we have container-based deployments. We have prepackaged deployments where you can just download it and get it running. If you want to compile from source or build from source and check it out, check out the latest from the head of GitHub, you can still do that if you're feeling experimental. But if you just want a stable version to build and test and play against, those are now available for download for you via Docker Hub. We've yet again reduced the footprint of OSM, so it's got a very small containerized footprint so that you can deploy it on a laptop. You can run around with it on a USB stick. We actually distribute Vagrant images on a USB stick every time we have our hackathons so that no one has to bother to download anything. So it's dead easy to install now. And that was a direct result of community feedback. So we addressed that, and I think we've really made significant improvements there. The improved stability and testing, we're not going to get into it today, but we've sort of extended and augmented our whole CI/CD pipeline and automated a lot of tests and built and sort of mandated making test-driven development part of the OSM core tenets. And so as we develop new features, we adhere to some of those test-driven models so that we can automate those testing with nightly builds. Every time someone checks some code in, there's some end-to-end automated tests that run that not only do test against each individual function in the code, but end-to-end functionality tests. So simulating, using that northbound interface to simulate actually building a network service, actually pushing day 2 operations changes to it, and then tearing it down. This is all part of our automated CI/CD pipeline, where we're very close to achieving full regression tests in an automatic manner. And that's due largely to the fact that we've mandated that type of test-driven development. And then finally, we've added a feature for Vim account grouping, because we know in practice, you're typically not going to deploy OSM to manage just one Vim. You want to manage several Vims that might be in different locations. You want to be able to manage, red-green updates, so that if you have a Vim of one version and then one with an upper version, you want to be able to migrate those workloads between them. Instead of having just a list of Vim accounts that someone would have to scroll through and click through the UI or explicitly state, you can now define a group of Vims to say this network service applies to these Vims and this login applies to these Vims. And just being able to logically do that in the information model save people a lot of different pain points when deploying. So that marks the end of my presentation. I know I kind of rushed through a lot of the Release 5 features, but I just wanted to give you folks a little teaser so that when it does come out, you'll be excited to download and use it, or join us at one of our hackathons to get hands-on with it in the future. So I have a few minutes if there are any questions. Otherwise, I will hand it over to my colleague. Yeah? Oh, wait for the microphone.
Thank you. I was just wondering, now that you mentioned the WIM, the wide area management, and also talking about 5G sort of multi-domain issues, are you now extending collaboration? I think you are, so this is a little bit of a leading question. Are you extending collaboration with ETSI ZSM then? And any other standards bodies? I'm just curious.
Yeah, we keep close tabs on what's happening in those communities so that what we're building stays in that same vein, and we participate in those communities. Francisco Javier, I believe, is an active member of ZSM. So we're very involved in that community.
Hi, this is Joan from Docomo. Related to the previous question, what are the type or the protocols that they are considering for the multi-site connectivity aspects, the WIM?
So protocols...
Are you protocol leveraging certain standards or certain...
I believe the more detailed answer will come from my colleague.
Okay.
Yeah, so most probably here we are seeing an enhanced version of TAPI, Transport API. Okay, that's the one that we are considering here. Okay.
So this is a good segue to hand it over to Gerardo.
Okay, thank you, Vanessa.